Welcome to another episode of Saturday series. Today's topic is electric car changing transportation. So we are having Dr. KRM Vijay Chandrakala, who currently serves as the Associate Professor in the Department of Electrical and Electronics, Amrita School of Engineering, Coimbatore. She joined Amrita from 2009 and also an alumnus of Amrita School of Engineering, Coimbatore. She is awarded with Chancellor's Publication Excellence Award for her exemplary research during AIRA Awards. Before getting into the session, if you have any questions relating to this topic, you can just type it in our chat box. We will discuss it after the session. Without further ado, I would like to welcome Vijay Chandrakala ma'am to deliver today's session. Over to you, ma'am.
Thank you for the warm welcome and the opportunity. And I welcome all the people of all the generation who is going to watch right for today's content on the delivery on electric cars, changing transportation, right, which is a leading way towards changing transformation in the automobile industries around the world. So happy to get into the interesting and enthusiastic topic, and which is the escalator in terms of innovations and technological advancements. And it has become the heart of the vehicle, giving payment towards driverless or autonomous car evolution. So, getting into the content, I'll be briefing about the introduction, the paradigm in electric cars, or we even call it as electric vehicles, transformations in vehicle technology. What are the types of electric cars where the transformations has resulted? Then importance of the storage systems, which becomes an integral part on the electric vehicle. Then what is the requirement of having right a substitution or an extra attachment to the energy storage systems in vehicular technology, and different topologies is the constructional behavior of the hybrid energy storage system in electric vehicles. Then I'll be showing you a small case study on what we have deployed right at Amrita Coimbatore in terms of hybrid energy storage system in an electric vehicle and the references. So, if you see on the various aspects, right, on in terms of the energy requirement or the power requirement, already you would have seen that there are different types of loads which are consuming the power. So you could have seen that already your buildings, those are the consumers, right? Normal consumers, we people who are consuming the power, the energy from the grid. And apart from that, there is also industrial revolution, and which is taking a power, and it is moving forward with the energy sectors, right? So it is in requirement of large amount of power, and similarly, you can see that the power requirement when you even consider the transportation, that is also going to be the next part. So, what is the requirement is here you could have seen that when transportation is becoming a challenge with the existing grid, right, which is going to supply the power, it is going to add on as an extra load, and it is going to have the charging mechanisms, right? You have to charge your vehicle, you have to run your vehicle. That is all about the electric vehicles, right? So why this electric vehicle has taken right a more and much more aspect in the new era is certainly you could have seen that it is going to replace the conventional internal combustion engine, right? So the conventional internal combustion engine is a four-stroke engine, right, where you pump or give your fuel as petrol or diesel. Certainly these sources are going to get extinguished in the next few years. So we have to come with a solution to reduce this carbon footprinting. That means your carbon dioxide emission, which is going to create right global warming alarms, that has to be now compromised with terms of your electric vehicles. So that is where the environmental impacts, right, due to the fossil based vehicles, right, it has to be replaced in terms of electric vehicles. So what does an electric vehicle is all about? So electric vehicles is nothing but it does have a electric motor, right? And it is driven by means of a set of or a stack of batteries, right? So batteries are going to be a high energy density type of devices which will drive your vehicle, right, at convenient speed with no such disturbances in your driving, and you can see a smooth driving pace that can be exempted onto the electric vehicle aspect. So even if you just see the people, right, who are interested to buy the electric vehicles, certainly in the market, when they are seeing the scenario, the Sensex shows that people are worried about buying an electric vehicle. Why? Because it is going to be something like a very costlier device, because it is yet to prove its innovation even in India and even in abroad. So this is where the research aspect one has to think, one or the common person is also thinking about when we are deploying or when we are going to buy an electric vehicle or an electric cars. So when you just see the scenario, right, I'm choosing as a vehicle or a car, it remains the same. So it is the transformations that is occurring on the mobility of the system, right? So if you just see a normal petrol or a diesel car, when you buy it, right, you buy it even for 5 lakhs or your 10 lakhs, depending upon your way, right, you are going to put it. But when you come across with the maintenance cost, certainly the movement, right, that the vehicle is going to get changed over, that will be happening in next 5 or 10 years, right? That is what is the replacement you do it for a petrol or a diesel type of vehicles. So when you spend money on electric vehicles, certainly it is the most advanced vehicles which are into the market, and it will impinge on the cost wise also, it will be higher. But when you just put the money on the maintenance, it will be merely less. So, what is the electric vehicle trend in India? Right? Why the whole world is behind the electric vehicles? It is to go with zero carbon footprint, and similarly, India is also moving on into this direction of electric vehicle. So already they have set up a national electric mobility mission plan, right, in the year 2020, and it deals with the issues related to the national security, pollution levels, the growth of domestic manufacturing capabilities. And if you could see here, in April 2019, Union Cabinet has sanctioned rupees 10,000 crore, right, program under the FAME 2 scheme. And what is the aspect, or what is the key information, or the key aspect of the future is faster adoption of electric and hybrid vehicles by offering incentives once you purchase your electric vehicles, and similarly it has to establish charging infrastructure for the electric vehicles. So you can see the percentage, right, where this electric vehicles are going to be deployed. You can see at the right hand side, right, Uttar Pradesh has taken almost, right, 26 percentage of your electric vehicles in terms of taxis. It is given, right, a way to establish itself. Similarly, Bihar with 10%, New Delhi again with 10%, West Bengal with 9%, then Karnataka with 8%, and so on, right? So here, where the India is focusing that in next few years, right, around 10 to 15 years, as per the signed treaty, it is around 2030 that is expected to employ, or to have a deployment of the total electric vehicles in Indian scenario. So all your petrol, gasoline, and as well as diesel-based your vehicles, right, or cars will be replaced with electric vehicles. That is where the mission, or the national mission of our India. And you can see that which and all companies are going to collaborate for the establishment of these electric vehicles. Right, these are more familiar, that as you see Mahindra, Bajaj, right, then Volvo, and you can see in two-wheelers with Hero Honda, right? So these are the vehicles which are the companies which will be a part of electric vehicle deployment. Now let us see, like, what is the transformation of this vehicular technology? So how does it has been transformed? Now, who is the founder, or who is the person behind to set up, right, to do the innovation in the car technology? So we can see a short video, right? So that will tell us the first launched cars in the world. So it has given you an idea about how in 1800 and 1900, right, an automobile is run by steam, right, and how an internal combustion engine is powered by hydrogen, right. So this is not something like newly which is being existing or which is just started just a few years back, right. Think about in 1800 to 1900 itself, this evolution has happened, right. But the thing is, they failed in the innovation development where the people, right, certainly the people and the industries have to correlate and bring it up. And you can see petrol or gasoline powered vehicles, right. So this is where the vehicle technology has come in, and who is the man behind it? It is the Benz. So Benz has made the first landmark in vehicle technology. And from Benz, you can see in another video where there will be different other type of industries, right, that has competed along with the Benz to establish, right, as a landmark and as a vehicle, right, as an electric vehicle and the car transformations that has happened. So we shall see in another video. So this video would have given an idea about like how a car, right, in terms of its body, in terms of its tires, in terms of the people it is going to accommodate, right, inside the car, right, to sit comfortably, very feasibly, very elegant, very luxurious, right? And you could have seen that there is also evolution of car industries that has happened in 19th century. So that is where the Benz has given a way, right, for the industrial revolution to happen in the automobile technologies. So you would have seen, right, in this video regarding different other companies, right, along with Benz, Renault, Ford, Citroen, right? This is not a new car, it's a very oldest car industry which is existing. Rolls-Royce, Jaguar, Honda, Chevrolet, BMW, and Audi. Certainly, these cars and these car industries you're seeing day, right, every time whenever you move on to your roads. So these establishment of industries, right, it is carrying forward from 1900 onwards. So now let us quickly see what are the paradigm that has happened in electric cars and vehicles, right? So nowadays, if you would have seen the car technology, right, you're having panoramic sunroofs, right? You will be having a power steering. You will be having the interior trimming, right? You will have an airbags, the seating comfort, right? So it is something like you just compare with an ambassador car, right? And nowadays what cars you are having it, right? It is having a very sophisticated way of elegance that is happening inside. So you can see how does the interior looks like, right? And you could have even seen that how logos and the emblems are also being changing. Sometimes it will be written over the car, sometimes it will be like a stamped over the car, and sometimes it will be something like an emblem which will be fixed on the car. So exterior and interior trimming is happening in the car technologies to appear, right, to grasp the appearance once you see the car to buy. And similarly, when you drive the car, it should be much comfortable enough, right, rather than stressing yourself, because we people, right, you know it from all the generations, right, even from the kids to the elders, right, everybody is running behind one or the other thing, so already being in stressed, right? And again, you think about a vehicle that you want to draw with such a stress, certainly you will not be preferring to buy the vehicle, right? So there are innovations that has happened under transmission. Now what is this transmission, right? So if you just see, you are having a transmission, right, in a vehicle. Once you just go through it, it is something like manual transmission, right? So the vehicle will go in respective levels of speed, right? Once you press your clutch, right, and once you change your gear, right? So you will be having something like 4 gear, 5 gear, or 6 gears, right? That is where the transformation and the advancements it has happened. Even 7 gear type of transmission is also there, which we call it as manual transmission. That means you press the clutch and you take it from first gear to second gear to third gear, with depending upon the speed limits, right? Between from 10 to 20, then 20 to 40, then 40 to 60 or 80, right? So a manual transmission is now, right, is now in various cars. It has been supported even with automatic gear system. You call it as automatic transmission type. So under that automatic transmission type, what is happening is you need not, the clutch will not be there automatically. Gear will be adjusted with respect to the speed you are going to take your vehicle. So mostly the person who is getting inside a crowded area or a crowded place, right, a crowded road, then certainly a smooth driving is what is required by the people, right? So under that, the automatic transmission system is the one which is opted by the people who are driving inside the busy roads, because you need not have to worry about, because the putting in first gear, second gear, then suddenly the vehicle which is in front of you, right, in a crowded place, it just comes back and suddenly you put a brake, then something like you are already stressed and you are going to change your vehicle under such a scenario, under different gear mechanism to set up your speed. People preferring for manual transmission is less. That's where the automatic gear system has come inside, wherein which you are stress free and automatically your vehicle will set the gear, right, automatically into different pace of speed when you are accelerating it or decelerating it. Okay, so and even if you have seen the steering, right, the nowadays the steering are called as power steering. So power steering is, it senses the driver, right, the torque or the driving speed. When you are going to shift your steering, it just reads the system, the computer system which is inside the vehicle, which just sense, right, what is the required pace the vehicle has to go, left or right or straight, right. So in that aspect, your power steering is very sensible enough, right. You need not have to rotate a huge long, right, like an older mechanism when you were rotating your your steering vehicle. So older type of steering system is a ball steering system. So you have to put a stress to take a one complete round. But whereas here, you, even if you just turn a small angle of 1 degree or 2 degree, you can have a little bit a steeper enough of driving. So you can think about how flexible it has become even in the steering and as well as the braking system. Earlier braking system, you have to put your pressure, right, put your feet pressure on the brake. So now braking system is very slight touch. If you just give it, your vehicle will stop on the time or on the par, right? So these are the different advancements that has happened even in the interior part of the vehicle behavior, right? How it goes on the road. You can see here the early type of steering. It was hydraulic, so very tight enough to even turn your vehicle steering. But nowadays it is electric steering. So the computer systems, the sensors which are connected to your steering system will sense at what level the driver is intending to move your vehicle. Depending upon that, the wheel will be aligned. Similarly, to break the, if you just see the current booster or the I booster, this is the amplification, that is the braking mechanism is going to give. Earlier it was air and vacuum, now it is electrically being driven. So there are the parts which wherein which the hydraulic system, the mechanical system are equipped with sensors, right, and a mechanism of computer level to understand what is all about this vehicle wants, what is all about a person who is going to drive the vehicle. So you can see here from IC, that is internal combustion engine, right? Yeah, this is the company, right? Gold company, and it has transformation that has happened in an EV by General Motors. So this is how the mechanical systems, even it is being which are being overlaying, right, is being now overcome by means of the electrical mechanisms. Now, what are the transformations in the vehicle technology that has occurred, right? So nowadays also you could see onto the road or in your homes whenever the two-wheelers you're using it, or three-wheelers you're using it, and even for four-wheelers like cars, you're going to use it. You pump, right? You give the fuel as the petrol or the diesel. Even gas type of operated vehicles are also there. But that is where you can see here that this is made up of an internal combustion engine which is fueled by either petrol or diesel, right? So the internal mechanism, you know it, that the combustion engine will be spark ignited as you push your fuel system inside and it drives the vehicle, right? So and even it has a battery mechanism. It's an auxiliary battery which will only switch on and off of your internal lights like headlights, automatic wiper, the power windows. So those will be operated by a lower energy level of batteries. Now that is where the earlier or the present system where few vehicles are working even with petrol or diesel, that's where the evolution is happening, that they have to move right towards hybrid electric vehicle. So what is this hybrid? Hybrid, you can see here that you are having a fuel, right, which will have internal combustion engine also, right? By petrol or diesel, when you give it, the internal combustion engine will drive your vehicle at certain distance. If you want to switch on, right, towards the battery mechanism, you can see there is an onboard charger, right, a traction motor. So battery is going to power your electric vehicle, right? And in order to have, right, a proper amount of battery charge, right, because it has to sense whether your battery is being charged fully or halfway, or it is not charged, then it has to indicate that your battery level is very low and you have to take forward for either stacking another battery, or you have to do the charging of the battery. Right, so this is going to be something like a hybrid, which facilitates your battery supported with the fuel, that is petrol or diesel. So you can make your vehicle to take in two ways to operate, via the fuel and via your battery mechanisms. Similarly, you can see here that instead of now, because relying on petrol and diesel, right, and since the mission of the world is also moving towards having a zero carbon footprint, then certainly all your vehicles has to be taken owned, right, or it has to be run by means of fully operated battery EVs. Right, so you can see here that there is no fuel mechanism, right, either petrol or diesel. You are going to fill it up, and you can see that here, right, there are a set of batteries which are being stacked just below the seat where you sit in the car, right? So as you sit inside your car, below the seaters there are stacks of batteries which are either series connected or parallel connected, right? And there is a traction motor and a converter, right, which will balance the energy that is required by your motor to take on its pace. So such type of fully battery operated, only with battery operated electric vehicle, we call it as electric vehicle. It's something like it's an electric source, right, which is going to drive your vehicle. Now there is an evolution that is actually thinking about to go with the hydrogen based vehicles, which we call it as fuel cell electric vehicle. In short, it is FCEV. So you would have seen even in the advertisements like Hyundai, right? They are moving forward with fuel cell type of deployment of electric vehicles. So it's an easy mechanism, right? Hydrogen from the tank, it will be pumped inside, right? A catalyst or the membranous drain is there, which will just combine the oxygen from the air, and you can see what is the byproduct that is going out. That is a pure water, H2O, right? And again, if you just extract hydrogen out of it, you can certainly again fill that car. Within the car itself, this mechanism can be moved forward, right? And oxygen can be only the exhaust that can go out of the vehicle. So think about that, it will be a purely, right, e-green vehicle where zero carbon emission you can think about. So this is the future where the hydrogen tanks and hydrogen vehicles will be coming inside, which is going to work. Only thing is the safety and the precautions are the much most important things so far the hydrogen is concerned, because it is highly inflammable, right? Highly flammable. When it is exposed towards your environment, then certainly you have to take the precautions. So what are the type of electric cars or vehicle, right, that are operated? So it is the battery operated electric vehicle. So how does it operate? So it has a stack of batteries which will be connected either series or parallel. It is going to store your charge or the electricity on board, and those battery packs are of very high capacity, because your machine, right, or your vehicle or your car, when you're driving it, certainly the expected speed, right, on highways is around 100 kilometer per hour or 120 kilometer per hour. This is the speed that is expected. To achieve that speed in a comfortable zone, certainly the battery energy that should be released, and it should take care of for a longer amount of miles it has to carry, certainly it should be of higher capacity. So whenever you have such type of battery operated vehicles, certainly a person who is having a petrol and a diesel vehicle, they have their own nearby, right? Every 1 kilometer you have your own petrol tanks, right, where you can fill it up easily. You can drive it. Maintenance also a little bit free, because if you just see, the companies are also, those who are marketing, they are having their own establishments, right, under this petrol or diesel, which is a long way the vehicle technology has been prevailing. But when you come across with an electric vehicle or electric car, right, when you are purchasing, the first thing comes into your mind is, if suppose this car battery is discharged at a very faster pace and suddenly it stops at the mid of the way, right, where no person is there, then you will only think about the charging infrastructure. Right. So how well these chargers, right? The chargers has to be kept, right? That is another thing that a research field is going on. Like how far you can have an optimal location for these chargers to be deployed, and there are different levels of chargers depending upon your voltage level. So level 1, if you just see, right, it is given with a voltage level range of 110 to 120 volts, and since charging time, you think about 8 hours, right? It is taking a long amount of period to charge your vehicle overnight, right? And what is the miles that is expected per 3 to 5 miles? Certainly this level 1 is going to bug the people, because you're investing such an amount on an electric vehicle when you're purchasing it, and certainly you are going to put your electric vehicle for 8 hours of charging, and this is going to suck you, right, at one instant, that preferably the household charging only that is possible here. So when you go up with a long charging time, because everybody in this world is very faster pace, they are thinking that everything should come in within a second of time, and everything should happen in within a second of time, right? You have no time to even wait. That is the scenario. So 8 hours of charging at home or at workplace can only be preferred, but it is too longer to establish the level 1 of charging infrastructure. When you move on with level 2, the voltage level, they have made the level 2 to be operate between 208 to 240 volts with 4 hours of charging. So just think about half of the value it is being reduced, and preferably what they are using is to charge these batteries, it will be either wall socket type. It's something like you are filling a fuel based vehicle with a petrol or a diesel in the petrol pumps or diesel tanks. So what they do it, they just pull out, right, a thing like a gun type of thing, that it is connected to a fuel tank, and you just insert it towards the vehicle, right, to pump it with the respective fuel. Petrol or diesel will be filled for 1000 rupees or 2000 rupees. But here what is happening, so whenever a vehicle is get it is getting inside the charging station, right, at that instant you can have a wall socket or a portable charger will be there. And when you insert the charger, the car will first ask about, because it's a charging station, right, it will have a higher capacity than a car capacity, right? It has to charge. Now how does it reach? So a gas station may have a high power, and you want only a power requirement as per your vehicle, then it will ask for what is the power capacity of the vehicle it has to pump in. Then only that much amount of power is required for your battery to be charged. So it's something like a sensing element whenever even a car gets into a charging infrastructure to charge your vehicle. And since it is 4 hours of charging, 12 to 80 miles per hour that is expected, and you will be having a public stations like your petrol pumps. Here and after you will be having a dedicated electric charging ports. If not, then wherever you're parking your vehicle, right, you're parking your vehicle in the commercial places, you're parking your vehicle in the your own workplaces, you're parking your vehicle in your homes, right, then these type of places will have their own wall sockets or portable chargers where you can plug in and you can charge your vehicle. Level 3 is a DC fast charging vehicle. So you can see here that the vehicle which will be charged within a very few minutes, that is the expectation, right? So here you can see 30 minutes is enough for 200 to 600 volts, and a dedicated EV charging station is what is requested. So basically if you just see, Tesla is the person, right, Elon Musk, he is the CEO of Tesla, who has given a proprietorship for this DC fast charging infrastructure. And they have their own charging plug, which they call it as CHADEMO. This is called as something like a CHADEMO. Right, that is the dedicated proprietary plug where they can only charge with using those plugs. So it's something like ownership Tesla is having it onto the charging infrastructure where they are going to deploy under UK or US. Now, when you just see Nissan type of vehicles and as well as your Mitsubishi, right? These type of vehicles, they have combined charging systems. That means a vehicle of Nissan can use a charging port of a Mitsubishi. So it's something like a to and fro mutually compromise. They are having this. So there also a charging port who is going to deploy. Private players are going to play a part. So that's where dedicated with the high fast charging stations are being planned with, and it takes for 90 miles. So you can see battery operated vehicle manufacturers are, these names are known to you. Tesla is there, right? You could have even see Kia, right, which has come inside India, and it has taken a good market pace, right? And Tesla cars, right? It has to come into India when its price goes down and it is affordable by the Indian people. Then you have Hyundai, right? So these are the known BEVs, automotive companies which are going to deploy. Next is your plug-in hybrid electric vehicle. So it is something like you're going to plug your electric vehicle which can recharge your battery. And if you just stop your vehicle, sudden brake, if you apply that kinetic energy which is stored in your brake, right? That energy is enough to even charge your battery. So this becomes something like plug-in, and the vehicle which is going to apply it with the brake, and that will also get power in the reverse direction. So it's going to have a purpose. And hybrid means certainly it will be having a parallel operation from the fueled type like petrol or diesel to power your internal combustion engine. So these are plug-in hybrid vehicles in Indian scenario and even in abroad, right? These automotive companies have established under the plug-in hybrid. So you're well much known about this Mini Cooper, right? You would have heard about it. Mercedes, BMW, Kia Optima, Porsche, right? So these are the vehicle companies and the vehicles which are there for under plug-in hybrid vehicle. Now, coming on to these batteries, right? Batteries becomes as the major source for the electric vehicle or the motor which is present inside the electric vehicle to drive your cars. Right. So the much familiar part, the batteries are of lithium-ion batteries. Right. There are even other batteries which works on molten salt, nickel metal hydride, and lithium sulfur. It has its own properties and it has its own disadvantages. You can see over here when you map it for easy access, inexpensive, energy efficient, temperature performance, weight, and life cycle. Right. Lithium-ion battery uh, will like meet all the requirements, right, when compared to nickel metal or lead acid batteries. And there are even other batteries across the other parts of the world, right? They are making use of lithium sulfur. So that's where the evolution of even the batteries is also happening. But the major, if you just see the advantages and the laying of the batteries, you can see here it is under just the seat, right? You are having the battery stacks which are either kept right in series or in parallel, and you are having the battery to increase the voltage, power capacity to be increased. So it's a very high, it is having a very high energy density, high voltage, low self discharge rate, long cycle, high charging and discharging rate capability. That's why people prefer for lithium ion batteries. Now, since these batteries are going to power your electric motors, which is present in electric vehicles, so what type of motors are actually present, right? That takes into account this battery to be powered with. So there are different types of electric motors like DC series motors, right? It was earlier used in 1990s, but nowadays it is replaced with brushless DC motor, two-wheeler and four-wheeler, and there is permanent magnet synchronous motor, like PMSM, which is basically used for four-wheelers. Those are going to be your Tesla cars. They make use of this PMSM motors, and three-phase induction motors also with four-wheelers. So it depends upon how smooth, how efficient, how the torque or the speed, the requirement can be met. And these are the different the scenarios or the pictures that shows that motors of your that are present in your electric vehicle. So battery powers your electric motor. So now you will be a little bit familiar enough that what type of motors are actually being connected with the batteries. So you can understand from this graph, right, the energy density and as well as the specific or volumetric, both energy density, if you just compare with other type of batteries, lithium ion battery is having, right, its own pace, and it is having a higher energy density. But what happens is if your vehicle, right, suddenly you just put a brake or suddenly you give an acceleration, what happens is these vehicle, right, which is powered by electric motors, and that is getting the power from your batteries, which are the energy, right, it is going to take the energy of the battery for 3 hours or 5 hours of time, and during the sudden acceleration or sudden deceleration there will be a high discharge from the batteries. So what will happen? It drains, right? It drains off. So if your energy capacity or the energy of your batteries is draining off, then certainly you cannot expect to drive your vehicle for 100 miles. So it fails to have the power density, right? So your batteries has lower power density because during this requirement of sudden acceleration, sudden deceleration, if you relieve the battery, right, coming into operation with some other device, then certainly it is going to pave way to extend the life of the battery. So what are the other devices that can be connected along with the lithium ion battery is the another task. So you can see the disadvantage. This disadvantage is giving a way towards a high power source devices which can operate along with the battery storage devices. So when you are having an energy source and a power source, right, energy source is going to be a battery, and along with that if you are having a power source or a power device which will take care of sudden acceleration, sudden deceleration, and sudden braking mechanisms, right, then certainly there should be something like an energy management which can happen. You can optimize or extend the life of your battery. And the solution is, you can see here that a lagoon plot is being shown here. So you can see that being a very high energy density device of lithium ion battery property, you can see high power density devices, the supercapacitors. Right. So supercapacitors will have high power density, much longer shelf and cycle life, right, than even compared with batteries. So now it is something like hybrid source, right? Hybrid source to drive your electric motor, because this is going to extend your battery life, right? Extend the efficiency of your battery by taking some of its job, right, onto the electric vehicle by making use of supercapacitors. So high energy density with high power density, and this is the research, right? This is the way that the electric vehicle transformation is going to happen. Now, how you are going to connect this hybrid energy storage systems? It can be connected in series or in parallel or in cascaded. So if you have a series type of interconnection, it has its own advantage. You can increase the output voltage. If the output voltage increases, you can store more energy. Now, when you come with a parallel type of connection, certainly voltage is constant and you are going to increase your current. So maximum current can be extracted. It will also increase the storable energy. It can increase even the capacity. Right. So if you want to do both the jobs, right, increase your output voltage and as well as maximize your current, you put in series and parallel combination. So combines the battery and as well as the supercapacitor, you can have the combination to move forward. And when this hybrid energy storage sources, right, while you connect it, the older scenario where something like it was not having any power distribution controller. That means whatever the your power or the energy is there, directly it will be fed to your machine, or directly it will be fed to the electric motor which is driving your vehicle, right? So it is having an inverter. It's something like a DC is converted to a AC type of machine, electric motors, which are of three-phase induction motors or three-phase brushless in BLDC motors you can connect with. So this type of arrangement, you call it as a powertrain, right? Which doesn't do any energy management, which doesn't does any energy management. It just takes into account whatever the power or the energy is there. It will drive your vehicle. So this is not preferably used, right? And which is not even taken into account under the driving the electric vehicle. But when you have, right, a source, right, a converter, then certainly a converter will levelize, right, what is the requirement of the power from each, and power and energy from each sources to drive your electric motor. So this type of arrangement, which with only one converter which is connected to a battery and as well as your high power device, which is a capacitor, it is going to drive your machine. So you can see that here the voltages of two sources, if it is only equal, it is going to drive your electric motor, or any such power or energy during sudden braking or sudden acceleration or deceleration. You can pick any power capacity or the energy capacity whichever is available. So to relieve the basically the battery, right, during such a scenario, you can make use of the capacitors to be connected to the electric vehicle. Now, if suppose once you see the fully active hybrid energy storage system, the fully active means there are two separate converters, and these two separate converters can disconnect any one sources whichever is available to drive your vehicle. So system losses is going to be very higher, because as you put the converters, then certainly you can expect the switching losses, because those are electronic devices, power electronic devices. Certainly it will lead to switching losses being introduced. So it is just comparison. If you just see to it, you can even reconfigure the different topologies. So different stacks in series or parallel you can choose, right, and you can configure as a programmable voltage or programmable capacity depending on the requirement of ampere maximum current you want to drive or maximum voltage you want to drive. But it is very tedious, because the input voltage adaptation with respect to the voltage regulators, certainly it is little bit difficult. And you could see here that as separate modules with a combination of energy capacity with output voltage levels with the current configurations in discrete steps, you can make a choice, and if something failure happens here, you can remove this module separately. So this becomes something like a flexibility towards the energy sources and the power sources you can connect it. And here it is also moving towards the research areas. So you can see, when compared to all the other hybrid energy storage mechanisms or the configurations, the most acceptable way of configuration is semi-active HESS. So you can see the cost, complexity, space and weight, efficiency, power flow control. So you can have a perfect way, right, to adopt or to have such a hybrid energy storage configuration to drive your electric motor. So this is one of the case study which I am taking, which is being worked right over at Amrita, where we have deployed the semi-active hybrid energy storage system. So here you can see a battery and a supercapacitor with a converter, and that is going to drive your vehicle. So there are in order to design, right, with respect to the manufacturing components which are present, right, a battery, the machine or the electric motor is for 48 volts for 3000 rpm. We have to meet the battery was available with 48 volts with supercapacitor, and the market level it was for 100 volts. So we need to reduce this voltage, right, and power your vehicle as per the requirement. And the design aspect is shown over here, and this is how the power flow that is being maintained across the electric vehicle to work at the respective speed levels. So mode 1, directly your electric motor of the electric car is going to take the power from the supercapacitor, and it will relieve, right, you put it in first gear or second gear when you're going to, or it is as such you are putting in a first gear or a second gear, right, to take your vehicle, to take off your vehicle. Certainly instead of putting pressure, right, instead of putting a battery into an operation, it is the battery supply is being not taken into account. First the supercapacitor, if it is charged, it is going to run your vehicle, then later the battery will come into the existence, because when the vehicle is into the starting position, right, you are making the motor to start, right, certainly it will drive more amount of current. So battery will be drained, right, at the initial instant itself. This should not happen, because at a long run you have to for smooth running, the battery is the only purpose that can be met for a electric vehicle. And in the mode 2, what has happened is at the running condition, the battery, if it is having a charge, right, it is a state of charge, it is around 70 to 90%, it will charge your supercapacitor. And as well, because once it has made an help for the vehicle to start, right, certainly the supercapacitor will be discharged. So at that instant, if the battery is having a capacity during the running period, it can charge it, and it can charge even the vehicle during the running operation. And if you are suddenly, right, at an instant you are accelerating or decelerating, here we have applied the load to accelerate or decelerate. So here you can see that the battery is going to charge your capacitor. At that instant, the capacitor is also meeting the speed of the machine to rotate. Now, this is the hardware setup of hybrid energy storage system in electric vehicle scenario. We have deployed it with a battery, supercapacitor, bidirectional converter, and BLDC motor. So you can see here, initially the supercapacitor will be taking the control at the starting of the machine. Then battery is going to take the rest of the moment under the running mode, and your supercapacitor charging and discharging is being mapped. And during mode 3, one thing you can see that the capacitor is going to charge, the battery is going to pump. When your load decreases, your battery is going to pump your battery is going to drive your electric vehicle. And as such, if you accelerate it to the respective speed, your ultra capacitor or supercapacitor is going to operate. So the mechanism which is being deployed as a hybrid energy storage system, which is a combination of battery and supercapacitor, and it is used to enhance the battery life, meeting the vehicle operation as desired very smoothly. And this is the work which is taken from the last paper, and there are other works which are being going on, right, under such scenario for development of onboard electric vehicle charger or semi-active hybrid energy storage system, then energy management by active cell balancing technique, and as well as fuel cell powered with making use of the maximum power point tracking and the DC to DC converter topologies. So you can see that the futuristic approach in the electric vehicle, right? This is the mark, right, or this is the improvement that is happening. So you are having a Dreamliner or a space shuttle, and you can see the Facebook and as well as all the Microsoft Office, which is going to get integrated. It is going to do with the data analytics, and you can see the futuristic car, which is going to be autonomous, right? And these will pay towards the new players under the software sector and as well as the hardware sectors to come in. So this video you can see, right, how well the future of the driving can be.
It's essentially sending text messages between cars.
These are the electric cars, which is actually contact.
Integrating laser technology. It was science fiction, but it isn't anymore.
It's your own personal ballet. Swipe, and now the car will park itself. One of the big features everybody's talking about when you talk about automotive technology, it's driverless vehicles. To see that wheel move, and yet there's no driver.
The sensor has detected alcohol around the driver's seat.
Right? Size is under the seat by the seat belt. You're going to have the tank. It was the byproduct. It's going to adapt with respect to the environment, comfort, infotainment. You can see the scenarios where it is going to track your vehicle via GPS, pause, right, at one instant, and even solar.
It's a way to take this vehicle off of the grid entirely.
So you could have seen that there will be much in advancements in terms of connected cars, autopilot, self-driving and self-parking cars, autonomous cars, adaptive driving assistance system, and fuel cell driven cars. So, and these technologies can only come up with the innovations and the technology advancements through electrical and electronics, right, which are going on its own pace, renewable energy, smart sensors, learning and adaptive techniques. So this is where, right, even the different companies, right, which are also collaborating with the different universities in their R&D projects to innovate, to make into account these advancements in the vehicle technology to become more autonomous, right? So these are the different companies who are going to play major role in the advancement of the automobile technology. These are the references. Thank you. Thank you for patiently, right, hearing and getting the knowledge of how the electrical vehicle transformations that has happened and going to happen in even in India. Thank you.
Thank you so much, ma'am. Session. You shared all the topics on the electric vehicles, like its technological advancement, its futuristic approach, its transmissions, transformation, and all. So it's really an informative sessions for those aspirants. And thank you all of you for joining us. That's all about today's session. We'll see you on next episode. Until then, it's me Parvati signing off.
Thanks.